We've taken special care to set up our tooling the first time when we were milling it so that we wouldn't have to fight it the rest of our lives. There's a CBR in here, for example, where it is 4 millimeters. This side needs to be 4 millimeters to this side if the tooling was the exact same thickness. So there's certain things on certain bikes you have to watch out for. So now that we've got this located this way, we're going to go ahead and push it forward. So as you can see, we've gone ahead and moved the bike forward, and we're getting ready now to go ahead and hook the tooling up. So we've got that on the one side, that on the other side. Put a little clip on here. Make sure nothing comes out while it's trying to do its work. Go ahead and put that on. It's a feisty clip. Okie doke. Very good. So the next thing we're going to do is we're not exactly 100% sure if this is going to be the right angle for this thing to pull at. And what I mean by that is if you're looking at the relationship of how this angle versus the tooling versus the way the bike's sitting on there. So what we're going to do is we're just going to give this thing a tug for a second, and we see that it doesn't look like it's collapsing the bike, nor does it look like it's lifting the bike up. So how about that? I lucked out again. Okay, so after we've gone ahead and just give this thing a slight tug to make sure it's not incredibly too high or too low, the next thing we're going to do is we're going to go ahead and tighten this up. And typically I just like to run that hole in there, which means that I need to lower this just a little tiny bit. There, that looks good. Then we're going to tighten this up right here. Okie doke, so then that's going to hold that in position. Then I'm just going to screw this down to that goes into there. So we're going to place a piece of tape on here now, because this is my little way of cheating on this. Next thing I'm going to do is make sure that the bike has taken a set. So if you can see the pointer moving a little bit, I'm not going to pull this out hard enough to bend anything, but I am going to pull this thing out enough so that we have a repeatable spot where the bike comes back to. Next thing that I do is I take and butt the square up to this pointer, and I get a line. Then I would go out here again, pull this thing a little bit, let it come back, and make sure that it repeats, and it really does. That's great. The next thing I would do is square this over from there. My start line. And then the next thing I need to do is calculate out how far I need to pull this. We remember we did the math, and it was 850 some thousandths when the distance from the top of the steering head to the contact patch on the wheel was 40 inches, but we're quite a bit less than that now, so we're going to go ahead and figure that out. So let's do it. So the first thing we need to do is we need to measure from the top of the steering head roughly to the surface that we're going to pull this on. And it's, let's say it's 30½ inches. So we know that our answer is going to come out less than 858 thousandths of an inch, which is what it was at 40 inches. So we're going to take our same factor, we're going to do the same thing we did over there, but instead of 40 inches, we're going to use 30. So it's going to be sine 1.23 equals, that gives us our factor of 21.4 thousandths per inch, times 30.5 inches equals 654 inches. So it's almost 200 thousandths less than it was at 40, which makes sense because it's about a quarter. Very good. So 654 so I just put this at 654. Line this up. Make a mark. Square this over. And this is where we're going to be, where we're going to end up at. So we'll go ahead and make our pull now. All right, so we're going to go ahead and add some pressure to this. And we're kind of pulling this thing nice and slow and easy and just making sure that we're not having anything move any way we don't want it to move. And if you look at this, you can see that we're already past the mark. I don't know if you can see that from there, but that's because frames, you have to move past the elastic point of the frame and into the plastic point of the frame to get it to move. So we're pulling this out quite a bit past the mark. We're going to let this go and we're going to see what our first pull did. All right, as I said before, this is kind of an art. I'm trying to figure out how far it's going to go till it springs back. As you can see, we're looking really good here. Okay, great. So now that we have this mark done, as we showed you before, we're going to remove the tape. And we're going to correct how far this is off this way. Okay, great. So this is the ram that we're going to use to move the bottom of the steering head over this way. And if you can see up here, this is what we're going to use to hold the top of it on this mark. So we're going to go ahead and bend that now. Okay, so we're still on up there and we got about half of what we wanted down here. Okay, so shake this thing around. How about that? Looks like I've been doing this for years. So our pointers are on the marks now and we're ready to measure this thing at the top. All right, so as you can see, we've slid the bike back in the jig now. And we have the Mega Max plugged into the bolts that I showed you earlier, which is the top tooling part of this. We have it braced against the back so that we have this at the correct attitude so that our dots are about in the center of the screen, if you can see the screen over there. And we have our tooling also hooked up on the top of our steering head, which is basically the tool that pushes this axis, that projects this axis onto this, which we use a hose clamp and it works just fine. If it's not within 0.4 of a thousandths, the Mega Max won't accept the measurement. And then we have our regular tooling that's 160 millimeters forward and our target bracket. So we're going to go ahead and measure the bike now. All right, so here we have our printout of the bike after it's been straightened. And this is kind of what it looks like after you've been doing this for a couple of years. You can see that we're within 1/100th of a degree on the camber, which would be the perpendicularity between the swing arm pivot and the steering head. We're within 4/100ths of a degree. We're actually 400 degrees longer than we really wanted to be. If you could do the math, heck, I'll do the math for you. We're 4/100ths of a degree long. We're allowed a 1/2 degree and we're 4/100ths of it. So if we go sine 0.04 equals times 40 equals, we're about 27 thousandths of an inch further. We're about 27 thousandths of an inch further out than this bike was stock. Even if the bike was brand new and perfect, it still wouldn't be nominal, so we're fine with that. The fact that the B measurement is within 1/10 of a millimeter and we're still a tiny bit short on our length A, which I'll remind you what that looks like. All right, and the length A measurement, as I was saying from the other screen, I'm sorry I didn't turn this over quicker, is the length A would be from the horizontal axis from that bolt in this case to the bottom of the steering head, and from the bottom of the steering head up is B. So we're within 1/10 of a millimeter on one and 1.3 millimeters on the other, which would be roughly 43 to 45 thousandths of an inch. So we're going to call this thing just absolutely wonderful, and thank you, and I hope this taught you something.